Hey team, it's Mr. Munro here again. We're going to be talking today about AO6, one of our most complex, one of our most difficult algebra AOs. It is for a linear equation, convert between tables, equations, and graphs. Now, because this AO is such a complex one, I'm actually going to break this tutorial up into three separate parts. For the first one, we're going to look at going from an equation to a table to a graph. In the second one, we'll talk about going from a table to an equation. And in the third one, we'll talk about going from a graph to an equation. So let's have a look at this first one. We're talking about equation to table to graph. I've got a little example here of what each one of these three things might look like. So here is our equation, which we're going to be talking about first. Remember, an equation is a mathematical expression where you have an answer at the end. It's not simply 2x plus 1, but it's y equals 2x plus 1. So that's the equation we're going to be looking at today, y equals 2x plus 1. This is a linear equation, which means when we draw the graph of it later on, we're going to end up with a straight line as opposed to a curved line. And you'll understand why that is, hopefully by the end of this lesson. So let's have a look at what we've got here. The general formula for the equation, or for what you'll often see written as the formula for these straight line equations, is this down here. Y equals mx plus c. Now, in this case here, x is our unknown value, just like it is the unknown up here. C is the constant. It's the amount that will constantly add on to each x, y. And in doing some research for this video, I tried to find out exactly where the m comes from in this one. The m normally denotes the gradient or the rise over the run of the particular line, how much it goes up or how much it goes down. Interestingly, there's no actual evidence for where the m came from. It's just one of those mathematical mysteries. But in this case, we're just going to call it the gradient. It's the amount that the line goes up or goes down as it moves from left to right. So to begin with, we're just going to do some simple algebraic substitution in order to create this table over here. What you'll see is I've got the x here and I have the y here. So what I'm going to do is I'm going to substitute each value of x into the equation and figure out what the y value is going to be. If you're unsure about how to do this, there is a previous video that I've done on substituting into equations. So if you're not sure, go back and have a look at that. But let's just have a look at the first one to see what exactly we get. So there's some space down here. Let's say we're dealing with x equals 0. So we're looking at y equals 2, 0, plus 1. That's going to cancel out to be 0. So in this case, y is going to be 1. Let's have a look at the second one. Y equals 2, 1, plus 1. And so that is going to end up being 2. So that is going to add to be 1. What you might have already noticed is that that constant is being added on at the end every single time. I'm adding on the 1 every single time. All right, let's go through and let's have a look at the next one now. Y equals 2, 2 plus 1, so that is 4, so that is 5. Once again, adding on that constant every single time afterwards, and you'll, by now, hopefully you've started to notice that the answer is going up by 2 every single time. That's because each time we are multiplying 2 by 1 more than previously. So in the next example, when we're looking at y equals 2 times 3 plus 1, we're adding on an extra 2. So that's now going to be 7, 9, 11, 13, 15. Once again, we can look at it and go, right, 7 times 2 plus 1, because we are going, in this example here, y equals 7 times 2 plus 1. So we're going 7 times 2, 14 plus 1. So if we want to break down that, just to hark back to that y equals mx plus c again, this is the constant, the part that you're adding on each time. And this is, in the case of a table, how much you're adding each time, or in the case of a negative value, how much you are subtracting each time. So in this case here, we are adding to each, we're going up to each time, and we are adding that one constant each time. So here's our table, and the tables are really, really useful. Whenever I talk to my students about this particular skill, this particular AO, I always emphasize the importance of the table. If you find yourself stuck with an equation that you don't know what it's going to look like, or you find yourself with a graph you don't know what the equation is going to be, I always strongly suggest that you start with a table. Okay, now let's take this table and let's put it into a graph. So this is just basic. Measurement graphing. So let's start now. Remember, x is always across, y is always up. If you get stuck as to how to remember that, x is quite literally across. So x is always across, y is up. So let's put our first value in here. We're looking at x equals 0, y equals 1. So we're going to go about here. Okay, our next one is x is 1, y is 3. Okay, x is 2, y is 5, x is 3, y is 7, and so on and so forth. Now, at this point, you will have noticed that we are dealing with a consistent line. Hence the reason why these are called straight line graphs. Let's get a line in here. So this is the reason why we're talking about straight line equations. This is why we're dealing with a linear equation. So what you see is you've got a straight line. It's not curving off, getting bigger, or it's not a consistent curve like a parabola like this. We're dealing with a straight line. Let's have a look at this graph and let's just break down some of the parts of this, because there's a couple of things that can happen with this graph, a couple of things that can change about this. It can start at different points, or it can slope differently. It might slope steeper, it might slope shallower. And the other thing it can do as well is, instead of going up, it could slope down. So let's have a think about what it is that makes this particular equation over here into this particular line over here. So first thing to note is the starting point. That is the y-intercept, this point here where it cuts through the y-axis. Now you'll notice it is plus 1. And the reason for that is because we're looking at this guy here. When x equals 0, which is here, y equals 1. Now that's as a result of that constant we talked about. That's as a result of that c value, that plus 1. So this over here, this y equals 2x plus 1, that plus 1 is the reason for that starting point on that y-axis. Now, you may have also noticed how much that line is increasing every single time it moves across. As it moves across 1, it's going up 2. And that's consistent. 1 up, 1 across, 2 up. 1 across, 2 up. That's because as the value here increases by 1, as the x value increases by 1, that's x this way, on our table, the y value is increasing by 2 each time. 1 up, 2 up, 1 up, 2 up, 1 up, 2 up, etc., etc. So that's the reason there. And just to recap, the reason that this is increasing by 2 every single time is because of this guy right here. So if we have a look at that formula again, if we look at that equation again, we've got y equals 2x plus 1. This 1 leads to this starting point. This identifies the y-intercept, the starting point of that line, and the 2x identifies the slope or the gradient of that graph. So that's a little bit of a general overview. If you are a little bit unsure about that, or if you want to recap or just solidify that knowledge, feel free to go back through, watch this video again from the start, ask questions, or if you think you've got the hang of it, if you know you're sort of thumb sideways as opposed to a thumbs down, then maybe move on to the second video on this, see if you can get your head around how to move from a table to an equation, and then maybe onto a graph to an equation. So that was the first video in the series looking at AO6 for a linear equation, converting between tables, equations, and graphs. Hope you found it useful. Well done, team. See you again next time.